Elasticsearch started off as a distributed document store, but it's much more than an irregular database, because databases are, I always say, very much like black and white. You store something and you want to retrieve that back. Search is much more about those shades of gray, like you are looking for a concept and you don't know exactly what you want, but you want to have the concept or some context around it.
If you could master one skill that you don't have right now, what would it be?
Since I go to a lot of meetups and conferences, I want to pick up sketchnoting.
That's a great idea. And it's hard to find someone that can do that, because generally you need at least like a little bit of domain understanding and knowledge, because it's like deep technical talks. And then finding someone that can like have the art, have the words, because they're also doing notes, like just being able to do all that stuff is like a tough skill to find. But those are really nice. Which person influenced you the most in your career?
I want to name Shai. He used to start Elasticsearch, I think from his bedroom more or less, and then was the CTO and the CEO, and now he's the CTO again. And because he found an interesting problem. By the way, do you know the backstory why he created Elasticsearch?
Hey folks, this is Alex. I always say that Elasticsearch is super powerful, but it also scares me because I just don't understand how it works in comparison and scaling and performance compared to other databases. Great episode today. I have Philipp Krenn. He's the head of DevRel for Elastic, and we just like deep dive on all that Elasticsearch stuff, like indexes and mappings and shards and replicas and how to think about performance and all that stuff. I learned a ton. I wish I would have had this 8 years ago when I was using Elasticsearch, but I think it'll be just useful for, just getting a good mental model of how Elasticsearch works. So I hope you enjoy it. If you have any questions, comments, guests, anything like that, feel free to reach out to Sean or to me. And with that, let's get to the show. Philipp, welcome to the show.
Thanks a lot for having me.
Yeah, so I'm excited to have you because Elasticsearch is in some ways my white whale. I feel like it's like this amazingly powerful thing, and I also don't know enough about it, so then it scares me a little bit. And you are the head of DevRel at Elastic, so I'm guessing there are not that many people on earth that would be better to sort of explain that to me. So with that introduction, maybe tell us a little bit more about you and your background.
Right. So I've been at Elastic for almost 8 years at this point. I've done a ton of events and just try to help out our users. And we're still on that mission to make it work for the developers and help them along. So hopefully we can avoid a bit of that white whale thing. Any complex system has its learning curve, and Elasticsearch is definitely no exception, but it's not magic and it shouldn't be scary. Most of the stuff, once you know it, is almost easy. I feel like that's always the problem for me. It's like once you know, then you know, and it's easy. Like for any other thing that you have learned. And once you know, it's like, oh yeah, of course.
Yep. Well, one thing I learned is like, it just surprised me how little developers know about databases and just like basic stuff, like basic indexes. And I'm talking like on a relational database, just like an index and how it works and how you should use it and stuff like that. And then Elasticsearch is just like another sort of level of power with like all the different things I'm being distributed, but also having like the inverted index and text searching, also now having like vectors and having semantic search for a while, like geo stuff, all sorts of things. And it's amazing in what it can do. But again, it's just like, you see people do bad things with it because people do bad things with relational databases, which have been around, straightforward forever. And now, just another level of complexity, but also power and all that stuff. So I'm excited to learn a lot of this stuff. And I think there's probably no one better here.
Cool. Yeah, it's a bit like the hammer and nail thing, right? If you only know one tool and you try to use it or abuse it for everything, then you get interesting results. And yeah, Elasticsearch can do a lot of stuff, but not everything.
Yep. Cool. Okay, so let's jump in and maybe just like very high level first, like what is Elasticsearch?
Elasticsearch started off as a distributed document store or search engine. I think search engine is what we commonly refer ourselves to, even though it is JSON documents that you put in. But it's much more than an irregular database, because databases are, I always say, very much like black and white. You store something and you want to retrieve that back. Search is much more about those shades of gray, like you are looking for a concept and you don't know exactly what you want, but you want to have the concept or some context around it. And that's where the search power is coming from. And Elasticsearch has developed amazingly well in full text search over many years. And then we also branched out to other areas because for us, logs, but also observability is very much a search problem. It's like the storing stuff is the boring part. What you want to do is you want to find the most recent or relevant errors or why something is happening with root cause analysis, or you want to have these problems that are for us basically a search problem. And then we have branched it out to observability and nowadays also to security, which for us is also a search problem. You want to find the bad stuff in your system before something really bad happens. So search is kind of like at the core of all of that.
Yeah, very cool. So in terms of like, I would say like broad use cases that you see, how would you break down how people are using it, maybe in terms of like rough percentages? And I like the categories I think of are, hey, I have a search box somewhere on my website where I'm searching through customer names or like big text documents or something like that. That one. More like internal operational search, like, you know, I'm dumping all my logs or metrics in there and trying to figure out what's going on, maybe that one. And then I think also like as an analytics engine, it's pretty good on doing aggregations and things, like very good at distributed compute basically and that stuff. So like maybe those three buckets, if there's other buckets you see a lot of, like how much do you see in these different buckets?
I mean, a lot, and B, the beauty of this is since everybody can just download it, we often don't know or almost surprised ourselves when we see it somewhere and it's like, oh, cool use case, or we didn't even know that. But yeah, I mean, the starting point was for many the search platform and like the search box. So if you use Stack Overflow and you search on Stack Overflow, that search is going through Elasticsearch in the background as one of many, many examples. The classic Elk stack for logs, also extremely widely used, so that has reached wide, and it has evolved also a lot to OpenTelemetry and being great with Kubernetes and all the things around that. Security is often a bit of a different beast, but that's also in there. And then, yes, you have these things where people use it more like a data store or an analytics engine. Kibana is a very powerful tool. So, for example, for our own team, I pulled together a lot of stats and we have our own OKRs and metrics. We have Kibana dashboards for everything. So we do use it for that a lot as well, just to aggregate what we do or how things are moving along in other parts of the company. So there is a wide use case and range of things you can do. It's sometimes just a question of like, what is the biggest one? I don't know. It's like, if you want to come back to the question, you can also then turn it around and kind of like say like, well, is it like in terms of the users that touch it, or is it like the installation size? Because like many logging clusters are very large, whereas search is often a smaller use case. So it's like, I can give you 5 different answers and all would be correct. I would stick to saying like search, I think, is the core one. And it's also, thanks to vector search and LLMs, a very hot topic. In terms of installation base, I guess logs and the classic Elk or evolved Elk, sometimes I call it Elk plus nowadays, is very widely used. And security has also gained a lot of foothold, especially in critical infrastructure.
Yep. You say evolved Elk or Elk plus. Tell me more about that.
I always say your old self is often your worst enemy. And that is for Elk, it's kind of like people started with that and it was great, but that was potentially 10 years ago or maybe 8 years ago. Like in terms of like products, it's 10 years or so. The problem is what was a best practice or worked back then is probably not a best practice or changed a lot nowadays. And we often see that people are still doing what they used to or was a best practice 8 years ago. And then we see them do that and it's like, it might not be optimal anymore, or there might be a newer competitor coming in and saying like, oh, this is all wrong, like you should do this differently. And then I'm always like, yes, we wanted to change, or we have been changing that for years and we try to tell everybody, but it's very hard to make people actually go through that. And Elk plus is my personal thing. This is not an official brand or anything. It's more like I think that the brand Elk is very strong and worked very well. And I have a prop here, or actually I have 2 props here. So
Perfect.
We have these in different sizes. These are the Elks. This is and the Elk is very hard to kill. Like those are still well known and very popular. So Elk is kind of like what we have been doing for a long time, but we have moved it along because it used to be Elasticsearch, Logstash, and Kibana. But for ingestion, there is beats like FileBeat or MetricBeat to as a lightweight agent or shipper to collect the data. Nowadays, we also have something called agent or fleet, because at some point, many people were like, there are too many beats. We don't want to install 5 different beats on each system. We just want to have one single agent. And Fleet is basically a centralized management for that you have in Kibana. You can just say like, roll out this policy across 100 nodes or 1,000 nodes and collect this type of data. So there has been a lot of development. Also, one of the problems, for example, for logs was that Elasticsearch was actually quite rigid. If you change the type of a column or a field, then it would just drop your entire log message on the floor and say like, well, this field is wrong. I don't know what to do. We are still in the process of making that a lot more lenient. It's like, even if one field is not right, we still keep everything else and we just store one as like raw or in a raw format and don't index it the right way, but we don't drop the entire message. So there is a lot of evolution going in there also in terms of like how to manage the data and how to manage time series better and automate a lot of the pain points away. That's why the classic ELK is still there, but it has gone through a lot of iterations, and that's why I'm keen of pulling people along whenever I see them use something that was a best practice 5 years ago, and I'm like, you're totally right. Nowadays, maybe I have these other things that you should be using that will make your life a lot easier.
Yep. Okay. Are there, staying on use cases really quickly, are there any use cases where you advocate people like, hey, don't really use Elasticsearch for that if they're thinking about Elasticsearch?
For background, what is actually storing the data in Elasticsearch is Apache Lucene, the library, which is more than 20 years old at this point. And the point of Lucene is really that it's an immutable data structure. So if you have something that updates extremely frequently, that is not a great use case. So if you have, for example, a counter for each page on your website and every time a user comes to your website and you would need to write or replace that and basically increment it by 1, and you have like this page has been visited, and then you have in there like 500, 501, 502. Every time you do that, we would need to take the entire document and not just replace that one field, but replace that entire document. That is a very expensive thing. The immutable nature has other advantages, and you could potentially structure data differently, that you just log every event and then you aggregate it at the end and say like, this page had 510 users, rather than updating one document 500 times to just have individual events. Maybe at some point you roll them up and say like, we had X users for this domain or this URL per day. And then you drop the individual documents because you don't need that granularity anymore. So there are totally ways to work around that, but there are also ways to just use it and hurt yourself. And Elasticsearch does not have multi-document transactions. So if you have that requirement, it will also not help you out.
Okay. So very fast moving, especially like counter type data. And then, and because of multi-document transactions, probably not like your straight OLTP store.
Yeah, I mean, it's not a relational database. There is no transaction semantic in like you start a transaction, you do multiple things, you close the transaction anymore. People have built all kinds of things to kind of like compensate for failures or do that. Where I'm not sure. If you really need multi-document transactions, maybe you need a different system.
Yep. Okay, sounds good. So let's dive into like terminology and concepts to make sure, like, 'cause I feel like I just don't understand it as well as I want. So starting with indexes and mappings. First of all, index. I guess describe an index, because it's different than an index in a relational database, right?
Yeah, index, even within Elasticsearch, is an overloaded term, because to index the verb is basically what we call to store a document, because since search is doing more work up front, that's what we call it, the index operation. And de-index it's something that holds related documents. Normally they have a similar structure. And those can then be broken up, because your next question will probably be about shards. So a shard is one piece.
Hold on. So an index, the noun, is basically like a table or a collection in MongoDB. It's like a grouping of data that has likely the same shape, not necessarily, but roughly.
We tried that comparison with tables early on. I don't think it worked so well. So I'm always flinching slightly when somebody says like a table, and it's like, yeah, more or less. I mean, let's say more or less. It's like what you normally do is you put related documents together in terms of like structure, because even though it's JSON, if a field can only have one data type, because there is what we call a mapping, it would be a schema in the relational world. So you would say the field name is of the type text, for example. It cannot be a number afterwards. Or it would need to be cast to a string type, basically. So there is a schema-like structure, so you shouldn't have totally different documents because you might have conflicts in that mapping. You might also have problems if the data is extremely sparse, that got better over time, but it was not very efficient in disk space. So if you have like totally varied data that has very little overlap, you're probably not getting a lot of benefit. The other thing, while I'm slightly meh about the table concept, is if you have anything that is more like a time series, like anything with a timestamp, like log events or metrics or whatever, you would have normally multiple indices, like maybe an index per whatever time span or amount of data. So you would have an index pattern basically, and then you would have some qualifier like which iteration this is.
So maybe more like a partitioned table in a relational database in that time series pattern, but like, yeah, I see what you're saying. Yep. Okay. And in terms of, if you're doing that time series pattern, is that because we want to keep indices like relatively small? Is it because it's easier to then drop an entire indice like when stuff ages out? Like what's the reason for, I guess, splitting up the...
Let's add that shard concept before diving into that, because that is kind of like the relevant unit here. So one index can have one or more so-called shards. It's basically you split up an index into multiple pieces. And then each piece can be on any node. So if you have one index, let's say we have 3 primary shards, it has 3 parts. Those could be on 3 different nodes. This is kind of like how do you do the distribution of the data. There's on top of the so-called primary shard, there's the concept of a replica shard, which is like the secondary copy for high availability and also to increase search throughput. Nowadays, by default, we only have 1 primary shard per index. It used to be 5. Many people didn't have enough data. That's kind of like coming back to what is the size of an index or a shard. So the rough idea for a shard is that it should be between 10 and 50 gigs of data. So if you have a lot of shards with just kilobytes, you're not doing yourself a service because that is just like extra overhead and you're not gaining a lot from that. If you make them huge, if a node goes down and you have a huge shard, it might take quite a while to replicate it somewhere else. And there are also some limits, very hard to reach, but like how large a shard could be in terms of like how many documents it contains and things like that. But 50 gigs or maybe a little larger is what normally works. For some search use cases, smaller might have some benefits as well, but it should be in I would always say double-digit gigabyte range. If you're much smaller, probably too much overhead. If you're much larger, you might have some hotspots, or it might just not, the distribution might not be as even as you want anymore. So you should keep that in mind.
I was gonna say, can I reshard an existing index, or do I have to,
So that's what I wanted to say. So the resharding concept that we have nowadays, it's like you can split or shrink shards, though it can only be a factor. That's why the initial number of primary shards in Elasticsearch was 5. Prime numbers are not great for that, because the only place where you can shrink down from 5 was 1. So nowadays we only have 1, so you can then split into whatever number you want almost. But if you think that to parallelize stuff today, you want to have like, let's say 4 primary shards, and then you want to reduce it to 2 primary shards after a week or so, that might make a lot more sense, whereas 5 only leaves you 1 place to go. So it's underscore split and shrink are the endpoints that you can use.
But when you're resharding, you have to essentially reshard the whole cluster. It's basically like you have to take every partition and cut it in half to double it, or you can take two partitions and merge it.
So you take one index and you basically change the number of primary shards for that index.
But I can't go from like 8 to 3. I could go like 8 to 4, 8 to 2.
No, it needs to be a factor.
Yeah.
And if you, for example, shrink, all the data needs to be on the same node. And the nice thing about that is the operation itself is then very fast because it will just symlink the data together. So the operation itself is pretty fast.
Okay. Wait, sorry. If you do what? If you split it, it has to be on the same node?
If you combine it.
Oh, combine it. Okay.
So because then it's on the same file system and then you can just symlink them together. And it doesn't need to move a ton of data around and it doesn't block anything. It's relatively, the operation or the call itself is relatively fast then. So there are some trade-offs around like what is possible with sharding today. Maybe we'll actually change it in the future. We'll see. But for most cases, that primary shard number is actually less of an issue nowadays because either you have a relatively static data set, then you don't need to change the number of primary shards very frequently, or you have something that is a time series data. Then we call it index lifecycle management, ILM, which is basically, it looks at it and says like, you configure a rule and say like every 50 gigs, roll over to a new index. So you will create very even sized shards and you don't need to ever split or shrink them because it will just, once it reaches the right threshold that you have configured, it will roll over to the next one and then the next one. So you don't need to touch those anymore. So there's a lot more plumbing nowadays. So that's why the size of shards, I mean, people can do those wrong and then it hurts. But it's like from an operational perspective, the tooling is so much better that it should not be as much of a burden anymore.
Gotcha. And if I recall, when you do a query, you can do like a wildcard on indexes you want to hit. Is that right? So like if you have time series, yeah, you don't have to like know all your different indices that when they've been rolled over, you can just say, hey, hit me metric star, and it's going to hit all the different indices.
Exactly. You can provide a wildcard. You can also provide a list, a comma-separated list. So you can say like search through these 5 indices, but just these 5. Or you just say this pattern. And then, of course, you can add a filter on top and only say like whatever the time frame is in the last month, just give me the data in that. So there is a lot of flexibility built in that. So ideally, once you set it up the right way, you don't have to think so much about the indices and charts anymore, but we hopefully abstracted that pretty well away. And that is one of the big differences to the early Elk stack, where you had to do a lot more manual work around that, or where you needed extra tooling that might run outside the cluster, whereas the ILM is part of the cluster, so it's just like configured and it's running within the Elasticsearch cluster to take care of that.
Yep. Okay, very cool. Let's talk a little bit about, so we talked about sharding, and so I do a lot with like DynamoDB, so that's what I'm thinking about here, and routing. I think of like routing, right? Like when I make a request to Dynamo, it's going to get routed to a specific partition to handle that request.
Yeah.
With Elastic, how often are people choosing a routing key versus just like saying basically distribute this document wherever, and now a query hits? I guess like talk about routing within Elasticsearch. When a document comes in, how does it get assigned to a shard?
This feels almost like a trick question. So there are multiple answers to this. So by default, what happens is if a document comes in and it has so we have a field that is called _ID, and either you provide that yourself or the cluster will generate one for you. And that will basically be hashed, so it's evenly distributed, and then calculated modulo the number of primary shards. And then you get out shard 2. And then the cluster knows that the primary shard 2 for this index lives here, and then it will route the data there. You can provide, so that is what happens. Either the fastest way is normally that Elasticsearch generates the IDs for you automatically. The problem is if you provide your own ID, then it might need to check, does this document exist? Do I create a new one or do I overwrite an existing one? So it's often faster when you just generate it and then we don't need to make any lookups if it exists. You can change this routing information, so you can provide an explicit routing key or it's underscore routing is the field that you can use. Why I'm slightly cautious is because I feel like people are often hurting themselves more than they are helping themselves. So the idea is that you co-locate related data, and then your query can just be answered. For example, I know there is a very big Austrian online banking system, and I think they have a mainframe in the background, but that's expensive and slow to query. And so they have had all of their data for 10 years or more in Elasticsearch. And they basically, I think your custom ID or whatever is the routing key. So my data is always on the same shard. So when they run a query, they only need to query a single shard and not the 50 or whatever other shards for all the other customers. There it makes a lot of sense. And they have that built in that is reasonably evenly distributed. I've seen that go totally wrong. Like I know an Austrian logistics company that used the country for the routing key. Happened that I think 80% of their customers were Austrian, or 80% of the shipments were Austrian. So 80% of the data went to the same shard. And then they added more nodes because they wanted to scale out, but that didn't help because everything was going to the same shard. So there they hurt themselves. So co-location can be a powerful feature, but if you do it wrong, it can be very painful. So that was one, what happens automatically, two, what you can do yourself. And then there's a third way now. So we have something that is called time series data stream, which is more like a time series database. And what time series databases normally exploit very well is the locality of data, that it compresses better. And this TSDS system that we have also uses, you basically have a couple of fields that you configure as routing keys. So the similar data will always be co-located. So there it's kind of like built in, but in a slightly guided way, or it's like a tool that is under the covers hidden there, and it's there and active and working for you. But it's a bit more guided, so you don't hurt yourself so much. But data locality is a big feature, as you know from other systems. It just depends on how you use it and how to really use that, because you want to avoid the hotspots. But if you have some locality, you can potentially make good use of that. And that's kind of like the story. But you had a question.
No. So I guess, the first question I was going to ask is like, how many, let's put aside the TSDS one and just look at the first two, either auto or specifying a routing key. How often do you guess people specify the routing key, or would you even recommend people specify the routing key? Or do you think it's like heavily in cases you see where it's like, hey, let it assign that automatically into the shard?
I want to say that 90% or 95% use the automated hashing of the ID, and then it just works. Also, again, I think it depends a bit on the use case, because for time series data, you might want to have similar data grouped together. For a full text search use case, there is often maybe not even a lot of locality that you can exploit, and then you just want to evenly distribute it. So there are these trade-offs, and they're also like in search accuracy, multiple shards can add minor variations that normally should even out, but it's another way how you can screw up your data weirdly. So unless you know what you're doing and you have a very good reason, I would not reach for custom routing.
What if I'm doing like a SaaS, and everything is sort of within an organization or a tenant. So all my queries are within an org or a tenant, like all of them. In that case, would it make sense to use the routing key and get that locality? Or should I just like take advantage of the system and say, no, let's fan that out and throw compute at it from these different nodes rather than sort of putting it on one node?
You know what our favorite saying is at Elastic, and it's the same as the favorite saying of every consultant?
What's that?
It depends.
Yeah, sure. Yep. Okay.
So I think for any reasonably complex question, the first answer will always be it depends, and then you need to give a better answer. So let me try to give a better answer as a follow-up. I think the main danger is that you might have smaller or larger customers and you might create hotspots. So I'm slightly cautious. If you know what you're doing really well, then maybe. But there are a lot of other optimizations in the system that maybe you don't need the locality to make best use of something. There is sometimes, depending on, like, for example, if you have time frames, it can figure out like this is the time frame covered by one shard, and then you don't need to look at the others actually. So I feel like it's slightly tricky to answer this in a case that will work for everything. I'm just slightly cautious that, yeah, if you know really well what you're doing and you want to squeeze out some optimization, maybe custom routing helps. I'm not sure this is the first thing to reach for, though.
Yep. Okay. And I think that's where I get tripped up because, like, again, I do a lot with Dynamo, which is like so heavy on the partition key and making sure you use that so you're going to one specific partition, or even thinking about Planet Scale, you know, if you're talking about sharded SQL or if you're talking about Mongo, like just like the shard key being important in your query, like you want it to be something that's used in all your queries, so you're going to one. Whereas Elastic is sort of on the other end of that spectrum and just saying, hey man, you know, they're going to be indexed well on each shard within the nodes there, and it's fine to do a scatter gather there and just sort of lean on that rather than trying to shard it well and now dealing with hotspotting and different size shard, different things like that.
If you push it and you have a very large use case or a very specific scenario, or you want to have specific data compression or whatever else, probably I think 90% of the users are served better by not thinking about that and letting the defaults work. And if you have that problem later on, I would return to that. But it would not be one of the first things to reach for.
Yeah. Okay. What about, is the query engine, I don't want to say like smart enough, but like, will it take, let's say I have an index that has a routing key, let's say it's tenant ID, and I provide a tenant ID in my query. Is it going to know, okay, I only need to hit this one shard now? Or is it going to like hit those other shards, but they're immediately going to be empty for that tenant and return quickly? Do you know what I'm saying?
Yeah.
Or same thing with like time series. Is it smart enough to sort of know, oh, that time range is only on this shard or something like that?
Yes. So for the time ranges, I think it's simpler because there you have some metadata on the shards, and then you can early terminate pretty quickly. I don't know the implementation details. If you have a routing key, if it will just figure out very quickly that you don't have any hits and then return or not. It will probably also depend on the type of query and what you do there. Also, in terms of queries, it's getting extra complicated because we have just a few months ago added a new query language and query engine. So there are multiple options now. So we had the historic query language, the query DSL and Elasticsearch is JSON. And maybe you start appreciating SQL more once you start typing JSON as a human. But it's great, especially for systems. I think it can be complicated for humans to type. So now we have relatively recently added a piped query language. So if you know CloudWatch or Splunk or Microsoft Custo, those are all piped query languages, and we have a similar pipe query language. And it's not just a language, it's also a query engine under the hood with various optimizations that tries to push more and more concepts down into Lucene, but that's also more block-oriented rather than row-oriented. So there are quite a few subtle differences at this point. That's why I'm like, when we say query languages, it's already getting tricky. But again, once you start pushing the system, then you can look into those. I think for the average user, those are not the first things I would look for or reach for.
Yep. Okay. All right. Last thing on terms of like terminology and things like this, replicas, which you talked about a little bit. So basically, I have an index. I'm going to shard it across. I'm going to shard it into multiple shards. Each one will have a primary and 0 to n replicas. Probably want at least one. Like, how much do you recommend for sort of high availability persons? Do you recommend like having 2 replicas so you have 3, or like what do you recommend there?
The replica terminology, by the way, is, I think, very confusing because depending on the system, the replica includes the primary or doesn't include it. So for us, we have the primary and then we have 0 to n replicas. We generally recommend 1 for high availability. But maybe let me take one step back. So how the write actually works is that you send your request as a JSON, whatever, to write, for example, to Elasticsearch to the cluster. And then we'll pick a random node normally. That is the so-called coordinating node. That coordinating node will figure out what is the primary shard for that document based on the ID or the routing.
And hold on just one sec. So the coordinator node can be it's a storage node potentially, but it's just for this request it happens to be a coordinator. It's not like a request router outside of the storage.
Yeah, let's just assume we have the simplest case where we have, for high availability, we need 3 nodes. So we can have a quorum. So we have 3 nodes that are data nodes and so-called master nodes to keep the cluster state running. So they're all data nodes. So your requests will round robin between them. And then one of them gets the right request. And that one, the coordinating node in that case, figures out what is the primary shard. And then it will send the data or forward the data to the primary shard. The primary shard will then apply that, forward it to the replica shard. You get the acknowledgement back from the replica. Then the primary acknowledges to the coordinating node, and then you acknowledge to the client. That is how a write works.
And sorry, on that write path, it synchronously waits until all replicas have acted before it returns.
It will only acknowledge back to the client once it has been written
to all replicas.
Yeah. It gets tricky if you have then more replicas, and then there is the chance of timeouts. But it will try to write to the majority of the replicas, but we don't want to make it too complicated now. But yeah, the happy path is that it's kind of like it gets forwarded to the primary, writes to the replica, acknowledges back to the primary, acknowledges back to the coordinating node, acknowledges back to the outside system. And then there are of course like timeouts and what happens if you have like 5 replicas. Do you need to write to all of them? And so we don't want to make it too complicated because those are getting outliers then.
Yeah. We don't mind complicated here though. I like doing deep dive, so I want to know. But if it's just like so edge, then you don't need to go into it. But
I mean, so maybe let me do the search first to explain why you might want to have more replicas. Because if you have a search or aggregation request that comes into a coordinating node again, that one figures out like all the shards that you need to query. And then it will pick either the primary or a replica shard for reading or searching the data. So it can go to either one. It doesn't always go to the primary.
And hold on just one sec. You said all the shards it needs to query, but in most cases, that's going to be every shard in the index, right?
Yes, sorry, but my thought was you have an index pattern, so it might be multiple indices, and then multiple indices might be many shards. So that's why I'm
okay. Yeah.
Yeah, it could be a single shard if you query one index with one primary shard, or it could be n. So it can be many, and then you query those, and it can be either a primary or a replica shard that you query. And there is an algorithm nowadays built in that it will kind of like keep track of which nodes are more or less busy. And if it has like multiple options, it will go to the least busy one, which helps you routing around like some busy or hotspotting nodes, for example, or like busy nodes because it's doing a garbage collection or whatever else.
And are those statistics based on that coordinating node in the request it's made recently, or are they sort of like gossiping around saying, oh, this is like a slower one, whatever?
So the thing is generally called adaptive replica selection. I thought the statistics come from the previous queries that you have been running.
From the previous, that specific node's previous queries, or like across your cluster?
Don't nail me down on that one, but I thought it was like the coordinating node is just basically piggybacking on like previous queries. I don't think we have extra things that we send around, though I have not looked at the implementation details for that in a while. But I thought it was part of the responses that you get. And then so the coordinating node will then collect all the sub results. And by the way, if you do a full text search, basically what you tell each shard is like, let's say you want the top 10 documents or something, it will tell each single shard, give me your top 10 documents, but only the ID and the so-called score, like how good the result is. It will then aggregate from all the shards, the top 10 documents overall. It will actually, in a second step, fetch those actual documents, and then it will send that back. We call it query then fetch. So first we query for each shard's best results, and then we actually fetch the documents that the globally top results. So we don't need to move a lot of data around, because if you, let's say you have a 1 kilobyte large document and you query 100 shards, there's a lot of data that you need to move around otherwise. And it's also like the coordinating node would need to then deserialize and serialize that again. So we skip all of that. We only actually get the documents that we need. And that is the case where having more primary shards helps you spread out the write load. Having more replica shards helps you spread out the read load, because you have more copies from which you can read.
Yep. Okay. But let's say you don't have any replicas at all. Adding doubling the number of shards that you have probably is not going to help you on the read side, because they're all taking the same query. Like, since they're doing scatter gather every time anyway, roughly it's again, it depends. But like generally, yeah.
I want to say it depends. We could probably set up a very weird cluster that you have 5 nodes, but you only have 2 primary shards, and then like only 2 nodes are doing all the work. And then if you add more shards, then if they distribute evenly, then it would be better. But yeah, generally, normally you have quite a few more primary shards or shards in total than nodes. So yeah.
Yeah. Okay. This is awesome. Now let's go into like, where do people hit bottlenecks? And I want to think of it both in terms of like what resource, like is it CPU memory constrained? Is it disk constrained? And then also, is it different on the write path, on the read path? Are people hitting more on the read path? Are they hitting more on the write path? So like, where do you see people like hitting bottlenecks with their Elasticsearch clusters? Again, there's a lot. Maybe just walk me through on the write path. Is it like, I guess, or maybe is it 50-50 between like reads and writes are the problem, or is like one of them tend to be more of an issue?
I mean, there are potentially so many things that people can do. So for example, one thing that you could do is we have something called an ingest pipeline to basically change documents on the way in. That's normally more CPU heavy.
And is that on a separate node, or is that happening on the coordinator, each data node when it's acting as coordinator?
It can happen on the data node. You could also have dedicated coordinating nodes that don't do anything other than this kind of like being a smart router, or you could even have a dedicated ingestion node. So you could break those out in larger clusters. If you have like 30 plus nodes or so, it might make sense. Also because you might have different hardware profiles, because that ingestion node might need more CPU, but might need less other things because it's just processing the data. Whereas a data node probably needs fast disks, and then as much memory as possible to keep stuff in memory in terms of caching. If you run large aggregations, maybe you will also need memory. Maybe you need some CPU to crunch some data. You will need sufficient network. So I think you can pretty much run out of any resource that you want, depending on how you hit it and like what is your read-write ratio. Also, for example, vector search in general, the data structures should, or HNSW, the small worlds is like the data structure that we use for vectors right now. Those should be in memory. They are normally the biggest constraint is the memory size that you have available, even though we have quantization now to reduce the memory and things like that. But their memory, for example, is a big constraint. If you have more like a logging use case where you store terabytes of data, probably the disk is the bigger thing, because there is no point or no way to keep all of that in memory, but you'll just need to fetch the right data pretty quickly from disk. There is also, especially for the time series case, we have normally data tiers where we say the data for today, this is where all the writes happen and probably most of the reads. And like from 3 days ago, then it's what we call a warm node anymore rather than a hot node that gets many reads but no writes anymore, and also fewer reads. And then there might be cold or frozen, which is mostly like once a week somebody runs a query that spans more than a month or so, or a full month or whatever. And there you might just want to be more patient. Maybe you add spinning disks somewhere, or you move it to a blob store just to reduce the cost. So there are a lot of different things that you can do there. And then Then, for example, if you have a lot of data on a blob store and you need to pull it in, maybe the network becomes a bigger bottleneck. I have a very hard time saying like there is this one thing that you will run out of. Normally, I think memory and disk is the first thing, but then you will need to keep an eye on what you're doing and the problems that arise from that to have that.
Are there certain things during the ingest pipeline that drive a lot of CPU? Like maybe if they're doing the built-in semantic search and that's generating vectors, is that pretty?
So we have another data type that's a machine learning node that's doing the inference and stuff like that. So that would normally be separate then, or that you would often do separate. Also because again, there more CPU is probably the hardware profile that you want on that one. Coming back to what is the bottleneck for ingestion. One thing that in Elastic we do a lot is grok, the named regular expressions. And regular expressions, especially if you write bad regular expressions, can be very CPU heavy or inefficient. So I always point to grok first. I'm not 100% sure this is always accurate, but I like pointing to grok because you can do horrible things with grok. And I always say that the plural of regex is regret. That it's A, nobody can read it, and B, it's also often very obscure to debug. And it's a great tool to parse apart what you have. So this is another thing. In the classic Elk stack, you would always use grok and parse. And I call this kind of like the Stockholm syndrome, that people got so used to doing that, that they think this is the right way. Ideally, you can have structured data when you write it already in your logs, for example. So if you write JSON, you don't need to do all the parsing anymore. So it's easier for you for not having to write grok patterns. And it's easier for your CPU because it doesn't need to do all of that parsing anymore. That's one of the classic ways where it's like, where I say like, the evolution of like, it doesn't have to be so heavy or painful if you move it in the right way.
Just, think about where you're doing that sort of stuff. Oh man, I remember working at a place and we had Elasticsearch and we were using, so grok is that the scripting language? Is that what you're saying?
Yeah, so grok is like these named regular expressions. It's basically a regular expression, but it has named patterns. So it has like for email or timestamp or log level, because it's basically, you can find it on GitHub or in the documentation. It's basically, these are the patterns that happen to all the people. So you can write your own regular expression, but you can also, 90% of the things, you can just use patterns that exist.
Yep. Or what about painless? What's painless? Is that also scripting?
Yeah. So painless is first a very unfortunate name. The backstory is that most data stores want to have some kind of scripting language. And Elasticsearch, when it started, Groovy as a dynamic Java or JVM-based language was the tool of choice. The problem is that Groovy was a general-purpose programming language, and people found ways to escape from that sandbox and take over clusters. And we had a couple of bad security issues. That is like 2010 to 13, 14, whatever. So old times. And then we made a strategic decision that we want to have a more specific scripting language just for Elasticsearch that runs on the JVM. It has some performance improvements because it doesn't need to reevaluate everything again, and it is like built so that there is no way to escape the sandbox, or some concepts just don't exist. It is, if you have written Java in the past, it kind of makes sense, or it will feel more familiar. If you have not written Java, it will feel potentially very foreign. The unfortunate thing is that we named it painless. It's not because we thought that the language is so painless, it's because the guy who created it mostly has chronic back pain. And his dream is to be pain-free, or painless. And so he called it painless. And I think I get once a month or so a complaint that painless is everything but painless. But it's a scripting language, or a purpose-built scripting language for Elasticsearch that you can use. But it is something that you need to learn. And while you might need that, unless you have to, I wouldn't. Also, because it can get a bit tricky to debug. It's not a language that you can run outside in your IDE easily. So it's just in terms of tooling and everything, it can be a bit tricky. We have made various improvements over time, and I think it's better now. But if you write 500 lines of painless, you will probably, again, regret your decisions. And maybe that's also not what you should be doing in a data store.
Yeah. And that's what I remember back the last time I used Elasticsearch, someone had written, I believe it was painless, some sort of scripting thing like within a query on a match, which just means like now your index, like it was like a keyword index, but they were using I think painless to like match on it, which just like blows your index, right? Because now you have to scan the whole index and like run that function over it, which is true in a relational database or anything else, but it's just like.
I see that every now and then. It is not a lot of fun to write. Maybe it's great for your hardware vendor or cloud provider, but otherwise it is not recommended.
Yeah. Okay. Okay. You mentioned Lucene, and I know Lucene is just like amazingly powerful. Is Lucene doing just the actual like text search indexing, or is it used for keyword indexing and other indexing types as well? Or is it just like the text part?
Everything. So Lucene is the thing that stores the data, any data on disk. Sometimes I get asked like, what is the database behind Elasticsearch? And sometimes I get asked like, is it MySQL? And we're like, no, there's no MySQL in there. It's just Lucene. So Lucene is the thing that analyzes your text. It creates the index structures. It writes them to disk. It runs the actual searches basically. Elasticsearch around it is basically the distribution part. It provides the query DSL or piped query language, ESQL, and it's kind of like doing a lot of the work on top, but it all builds on Lucene. And all the features in Elasticsearch are basically built in Lucene. That's kind of like the beauty. That's also why sometimes it takes a bit longer to implement something, because it needs to first land in Lucene, and only then can it be used in Elasticsearch. That's why the vector search or the KNN, the approximation search that uses the small worlds, took a while until it landed in Lucene, and then normally when there's a new major Lucene version, there's a new major Elasticsearch version, and once that came out, that was 8, but that was only like 2 years ago at this point. So that sometimes can take a while. On the other hand, Lucene is an established powerhouse and the full text search engine or library out there that we heavily build on to do all of that.
Is Elastic and the Elastic team, are they like I assume one of the main contributors to Lucene at this point? Like, are they, do they dominate that?
I think just 2 hours ago it was announced that somebody on the team got on the PMC, or we have a lot of contributors, and it is, Lucene is very strategic for us and we drive a lot of the initiatives. But there are also many others involved in Lucene. That's kind of like the power of Lucene, that it's not just one company, but it's very broad and then the foundation for many tools. But we do invest a lot. I don't have any statistics from the top of my head. There's also, we can again spin this any possible way. It's like the number of pull requests, the lines of code, the complexity of something built. I don't want to give any percentages here or say like, we are this big or not that big. But you will run into a lot of the Elastic colleagues if you do anything around Lucene.
Yep. Okay. Tell me a little bit about vectors, and you talked about HNSW, and I guess just like, I think of search and inverted index as like a much more compute intensive version of just like regular database indexing, right? Like normal B tree, like lookup type stuff. And inverted index is like, more storage, more compute to like make that match. And then I think HNSW is like another level above that. Am I thinking about that correctly?
I mean, so for classic keyword-based search, what the big trick I would say is that you do a lot of work upfront. So for example, when my go-to example is always from Star Wars, like these are not the droids you're looking for. What would end up in Elasticsearch or a search engine? So when you run that through Elasticsearch, if you run that, you will get droid you look. And what you can see is first we remove the stop words. We tokenized it, we broke it out into the individual words, and we did stemming. So rather than looking, it's only look. So it's the word root, because you normally don't care if it's like singular, plural, or what flexion of a verb, but you care about the concept. So you do that upfront, and then you store alphabetically sorted all of those terms. And then you basically point to all the documents where they appear. And then you know in the document it's at that position, so you could do highlighting, and you have the position, so you could do a phrase search. All of that is extracted basically at ingestion or index time. So your query is then pretty fast, because when your search query is coming in, you also analyze normally with the same analyzer the search query. And then you can just look for direct matches, because then you look for Droid. In your alphabetic list, you go down to this is where Droid is. Then you look like which documents contain Droid. These are the documents that are being returned. And that's why it's so fast, but it does more work and it creates those index structures to enable that. So that is extra work on top of that. And then what you do with vector search is you basically have these arrays of floating point values that have 100 or 1,000 dimensions. And then you just afterwards try to find something that has a similar vector representation. The trick for that is what the small worlds or HNSW is giving you is that you can do an approximation or an approximate search, like the approximate k nearest neighbors. KNN is generally the keyword for that. Because if you have 1 million documents and you need to compare like 1 million vectors, like how similar are they? This is computationally very expensive and probably not going to work out. And HNSW provides you with a smarter data structure that is layered and basically kind of like puts you closer to where you want from each layer. And then you can find in a relatively or actually very efficient way the nearest neighbors in a vector space.
Yeah. Okay. And so if I'm using an HNSW index, I'm naturally doing an approximate. Like I can't do an exact k nearest neighbors search with a HNSW index. Is that right?
Yeah, that is an approximation. And by the way, you can do without HNSW. So in previous versions, there was still a data structure that we call dense vector, which is this array of vectors. But then you couldn't do an approximation, but that was expensive. So you could do that before, but only since 8 has been 2 years, but still you can do the approximation or the approximate k nearest neighbors to get those. But that is like if you have a large amount of data, you want to do that. If you have something like 10,000 documents or so, HNSW is not going to help you. You can't just brute force that. That will be faster. And you can skip creating the data structure, but for large document or collections of documents, you want to have this approximation, because otherwise you just spend a lot of time on doing vector comparisons. Does
HNSW update well? Like if I have an update-y type workload where my vectors are actually changing?
Now we're coming back to one tricky aspect of Lucene, that it's immutable. So by the way, when I say immutable, how that works is, and you might have stumbled over the refresh rate at some point. So it's basically we batch all writes together. By default, it's every second, but you can change that if you want to have higher write throughput. So we batch all the operations in the last second together and create the so-called Lucene segment. That's at first only in memory, but will eventually be written to disk. This is the data structure that is searchable. That's also why it takes up to a second to find documents. If you retrieve it by ID, you can get it right away. If you search, any kind of like multi-document operation needs these segments. So it might take up to a second until that is created. You can block the write operation until the refresh happens, or you could force a refresh. Don't do that too frequently, because it will create many tiny segments and they need to be merged away later on, which is expensive. But so there are ways around that. But you have all of these segments. And eventually they get merged, because each segment basically contains a data structure on its own. And you don't want to search through thousands of them. So you want to merge them into larger ones over time. One of the downsides, though we have made some improvements there, is that HNSW, you cannot easily merge it. You basically need to recreate an HNSW. There are optimizations how we have sped that up, and also made like making concurrent searches across segments faster now. But it is a bit of a pain point that we're actively working on to make that merging faster. So one of the tricks we're doing now is we look at the different segments and look like which one is the largest one that doesn't have a lot of deletes, or which doesn't have deletes in it, because then we can basically use that as a foundation and then plop all the others on top of that, and we don't need to restart everything from scratch. But that's kind of like the downside of HNSW, that it's not easy to merge existing ones together. But there are ways to make that better. So anybody who is kind of like saying, oh, this will always be slow in Lucene and this is a horrible approach, there are improvements in that.
Just wait. Yeah. We're still early on that stuff. Yep. Okay. So these segments that get written, are they like a combination of indexes, like the inverted indexes, but then also the full documents?
They have multiple data structures in them, depending on what you have, because Lucene in general, even before vectors, had multiple data structures, because there is the inverted index, but there is also the uninverted index, because that's what you need for sorting, for example, or for aggregations. So there are different data structures and types how the data is stored. And there are text is stored differently than a number or a geopoint. And so there are different data structures to help you out in terms of query efficiency, but also storage efficiency, and just allow you to do specific things and features with them.
Yeah, gotcha. Okay. Last question I have before I move into just sort of the random questions thing. When Elastic is doing a query, or like when I think of a relational database query, maybe I have multiple filters in it, and based on statistics, I can say, okay, this is like, this is going to like cull it down the most. We'll use that one and then sort of go from there. Does Elastic sort of have to perform like all the searches, or like, especially like the search, like the inverted index lookup? Like even if let's say I have like a term match on some, like again, maybe a tenant ID, right? I only want to do search for users within this given tenant. So I use this tenant, but I have thousands of tenants. Is it going to be easy to like filter out all those other tenants, or is it just going to have to like, do the search and then sort of intersect it with the tenants that match?
Luckily, Lucene has been around for so long that there are a lot of optimizations in that by now. So
okay,
depending on what kind of filter you have, the filter can also be cached. That is one of the tricks that will make it very fast, but it can also kind of like generally limit it. It is also, there are some smart data structures. One of them is called max wand, which is basically allows you like an early termination. For example, one trick there is if you search for 3 terms, and it will figure out that one is very rare and that normally gives it a very high score, and the other 2 are less relevant or something is not as competitive anymore, it can early terminate some steps, and it will just do the most relevant things to get you the right results, and it knows when it can skip specific things.
Yeah. Okay. Interesting. I guess one last question on Elasticsearch. You mentioned like sort of, 8 is the latest version, has HNSW, all that. What does sort of upgrading an Elasticsearch cluster look like? Is that a pretty straightforward operation? Is it difficult? How do those usually go?
It depends. There are multiple more or less short answers to that. So Elasticsearch has for a long time operated on like major version means breaking changes, and there have always been some more or less, often unfortunately more painful changes. I think as we have matured over the time, things have improved a lot, and there are way fewer breaking changes, and it's not as complicated anymore. But there can always be breaking changes. The one thing that is a bit of a complication is that Lucene in general can write its current version and read one version back, but it cannot read further back than that. So if you have data written a long time ago and you have upgraded more than one major version, we have an upgrade assistant built in, and it will shout and tell you, you need to delete the data or reindex or rewrite it in the current version to keep it accessible. And by the way, these are the 5 settings that you need to change. So there is an upgrade assistant, and you can rolling upgrades. I think they came in 6 or so before it was stopped. But that was 2016 or 17 or whenever that feature came. It's so long I can not remember the version anymore. But rolling upgrades have been a thing for a long time. Most of the stuff you can just fix either through a reindex or changing some settings. If you, for example, had a cluster that was not using security and TLS, that probably will require a full restart, that you put all the nodes on TLS and then restart the cluster. So historically, it was not always super easy. I hope we've made it easier. There are also, I would say, ways around that to make it easier. So we have a cloud service, we have a Kubernetes operator. So there is a lot more tooling nowadays around all of that to help you. But I don't want to deny that, especially early on, like Elasticsearch upgrades were not always as fun as we would wish they were.
I think it's true that just like databases in general have really improved that. Where like, 10 years ago, that was not the case. Like, and people were major versions behind a lot just because it was such a pain to do that sort of stuff. So I think it's just gotten a lot better in the last 5-10 years.
Hopefully, I mean, we still see a lot of old clusters. And I mean, I can understand everybody has N tools they need to manage. And it's sometimes also a testament that it just works. So you don't worry about it anymore and then you forget about it. But then the upgrade at some point will be a major operation. I do see old or even ancient clusters. We, of course, always recommend like the most secure and by far fastest and stable version is probably the latest one. Or maybe if it's a rough release with a lot of features, the 0.1 release then. But that's generally the recommended version that you want to have. And otherwise, you just miss out on a lot of performance improvement, security, and bug fixes. So
new features. Yep. Very cool. Okay, this has been great. I feel like I know a lot more. Hopefully this will be helpful to others. We always end with just like some common questions I ask everyone, a little bit of rapid fire type stuff. So first question, if you could master one skill that you don't have right now, what would it be?
So the one thing that I want to do, and this is very random maybe, since I go to a lot of meetups and conferences, I want to pick up sketchnoting.
Oh, yes. When someone's doing a talk and it's like, yes, that'd be a...
Yeah, exactly. And then you put together this great overview because I think it's like very helpful. And it's like, I love it when somebody does that for my talks. And I don't see it much, but I think it's actually great if somebody really gets the gist out of that into one picture basically and makes a nice picture. And since I'm at so many events, I'm always like, I wish I could do that. Because it would be very cool also, like, as a takeaway for everybody from the talk. So maybe this is an uncommon one, but that is something.
No, that's a great idea. And it's hard to find someone that can do that because generally you need at least like a little bit of domain understanding and knowledge because it's like deep technical talks. And then finding someone that can like have the art, have the words, because they're also doing notes, like just being able to do all that stuff is like a tough skill to find. But those are really nice.
Yeah, I really want to do it. I'm really not a drawer, so I'll see how bad that it will look. On the other hand, maybe it just doesn't have to be pretty, but as long as it's more or less functional, it's still much better than nothing. So we'll see.
You should try it at a meetup or a conference this year. Give it a shot. Yeah, that's a great answer. All right, number 2, what wastes the most time in your day?
Yeah, I will always jokingly say at this point, I'm doing 80% management and 80% DevRel. Or sometimes I say like that DevRel is almost a hobby at some point anymore. No, but it's a good thing. I really love our products and what we do. And the only way to scale it out is through others. That's why I'm doing my best to build an amazing team and move us forward through that, because otherwise I'm always limited to myself. But it is taking a lot of my time, of course. But that is an important step to move us forward and get us to all the developers out there, because a podcast like this is great in terms of scaling. But we need to be on more shows, at more events, answer more questions on Discuss and Slack, write more blog posts, do more demos. We just need to scale this out, and I'll try to lead by example through that.
Yeah. Well, for those listening, he's talking about, Philipp's talking about doing this as his hobby time. It's like almost midnight. Is it 11:45 at your place right now?
Yeah, it's almost midnight. I just came off a meetup.
Yeah, right after a meetup, and he said he would be willing to do this podcast. So it truly is. That's amazing. All right, next question. If you could invest in one company that's not the company you work for, who would it be?
I think the mandatory choice right now is NVIDIA.
NVIDIA. Yep.
because everybody needs those GPUs right now. I guess right now you're too late already anyway, but it feels like this is the top of where everybody wants to be. And I think it's great to see all the excitement. I think we'll see how long lasting all of that is and where it goes next. But even though I feel like we're kind of like in a bit of a dry spell in IT to some degree, it's great to see that there is movement and things are working and there's a lot of innovation and excitement. And then I think NVIDIA is the perfect player in that thing right now.
Yep. Well, I made a mistake last week of saying I thought NVIDIA was overvalued, because they like passed Google and Amazon in their total value. And then earnings came out this week and they jumped like another 15-20%. So
yeah, and probably now it's too late. So don't take financial advice from me or none of the listeners, please. That is not what I'm good at. But I think it's a very interesting story because I feel like at some point people were a bit like, oh, the Bitcoin or a blockchain hype is over. Like nobody needs those GPUs anymore. And suddenly we need even more GPUs than before.
Yeah, I know. It's amazing. Yeah, they really set themselves up well for that. So, okay. What tool or technology could you not live without besides Elasticsearch?
Does it include our stack? Because I use our stack really every day.
Yeah.
I mean, that's a very tricky one. I'm very torn. So I have a shared background between ops and dev. And I think for ops, I feel like it's Linux in general and maybe automation like Terraform. And on the development side, I just did a lot of Java in the past. And I think it's also another surprisingly vibrant and resilient ecosystem that's also doing a lot of things and like also past a lot of its problems. So I'm not one of the Python people. I'm still one of the Java people, and we have LangChain4j and Spring AI and other things. So there's also movement there. And it's also fascinating because it's a very different take than the Jupyter Notebook world, for example, because when you look at a LangChain4j example, it often includes like tests, integration tests with test containers and Elasticsearch, for example. I saw something yesterday, which is like, I feel like the Jupyter Notebook world is very different. It's much more about experiments and it often doesn't have automated tests. And I'm just coming more from production and I really like production because that's where I like the pressure or where things happen. So I like that world.
Yeah, cool. Okay, which person influenced you the most in your career?
I feel like there were a lot of people that influenced us. I don't want to make this too much of a sob story or anything. It's like I want to name Shai. He used to start Elasticsearch, I think from his bedroom more or less, and then was the CTO and the CEO, and now he's the CTO again. And because he found an interesting problem. By the way, do you know the backstory why he created Elasticsearch? Maybe we can quickly bring this in here.
I do, but tell it. Yeah, this is a good one.
Okay, so his wife was becoming a chef, and she had a lot of recipes, and he wanted to write a recipe search. And he didn't find a good search system, so he started building a search system. Legend has it that she is still waiting for that recipe search because he got slightly distracted on the way. And Elasticsearch is kind of like the third implementation because there was Compass 1, Compass 2, and it wasn't Compass 3, but Elasticsearch, and 3 kind of like is the magic number maybe, I don't know. And that one stuck around. But that's where he got on the tech side. And at some point he took over more and more of the company and he didn't have time, or I don't want to say he wasn't allowed to write code anymore. That would maybe give the wrong impression. And I really liked his answer when he was asked like, do you miss writing code? And he's like, well, I'm mostly about solving problems. And at first the problem was to write the code, but now the problem is something else. And he has been there from the start and he's still there and pushing us. And I think that has been influential. And I remember back when I joined the company, I had an interview with him. And I remember it was very interesting because I he's Jewish, and I think he was in Israel at the time. And he scheduled the interview with him on the 25th of December at 9 a.m. or something like that. And I was like, well, he has kids, and if he can do that, I guess I can do this as well. And then I agreed to that. And then I think the evening before, he sent me an email which said like, oh crap, it's Christmas. We'll reschedule this. And then we rescheduled, and then we did the interview, and I was like, man, it's so hard to understand him, and it's so noisy. And at the end, he said like, well, this was great because my wife is driving and the 3 kids are in the back and I'm in the car, and that's where we did the interview. And since I survived that, I was like, okay, well, this all seems very manageable. So yeah, I think that's the person I picked for that.
That's great. Yep. I've seen him a little bit around, and yeah, it just seems like a great guy. And then obviously Elastic, great product, great company. And
he sometimes has, at least in the old days, he had a picture where he looked very mean, and like he has a shaved head, and it's like he looks very mean. He's not that mean. It might just look like that or threatening. Don't get the wrong impression. But at my previous company where I worked before, we were using Compass 2 already. So everybody knew about him, and we were always saying like, oh yeah, the search guy and the mean looking search guy. And I got to know the mean looking search guy a bit better.
That's great. Yeah, very cool. All right, last question. What is your probability that AI equals doom for the human race?
I'm always slightly pained here. I think there are so many steps on the path to humanity's doom at this point. I'm not sure AI is in the top 3 right now.
Is the last one? Okay.
I'm not sure. Yeah. Maybe it works its way up. On the other hand, I think the doom where AI is the doom is kind of like for the information on the internet, because the randomly generated noise in poor quality all over the place. I think it's not doom in itself, but it is a big pain point. And it also does, I think, to some degree, destroy some established communities. Like I mentioned Stack Overflow before, and I think their traffic took a big hit, but you can also see it in other places. And I think it makes sense, because why write the question on Stack Overflow and then either wait half a day for somebody to answer, or B, be told like, oh, this is a bad question, or like you shouldn't do this. When you can just ask any random thing to a chatbot and you get an answer right away. And oftentimes it's right. And ideally you try it out and figure out if this is really true or not. So I can see the appeal of that, but it does change a lot of the ecosystem, and like it has a big impact on like how people learn, and also where people exchange ideas and get to know each other and everything. And it's, I guess every win, like AI is clearly adding value and working for a lot of things, and we have products about like AI assistants that are doing a great job and are really helping make things easier and faster, but they do come at a cost.
Yeah, absolutely. Yeah, I agree. It's a weird world we're going into.
But like with anything else, I think it's not replacing the pain or bringing new pain. It's just exchanging the pain for something else. So it's solving something and adding something else. And it's always a combination. It's like, it depends. I think very few things have a clear-cut 100% answer, like it's like this, or it's good, or it's bad. The reality is more complex. On the other hand, I always say that complexity is great because it keeps all of us employed and for now, and entertained and busy, and we can learn things. So the complexity is to some degree a feature.
Yeah, absolutely. I love it. Well, hey, I appreciate you staying up this late and doing this and explaining Elasticsearch.
Thanks for having me. I hope we could reduce the complexity or confusion around Elasticsearch.
Definitely, yeah. Yep, this is great. This is truly great. I love it. I think it'll be helpful for a lot of people. If people want to find out more about you or Elastic, I guess, where should they go to find you?
I mean, Elastic is elastic.co, not .com, but .co, and then all the social media and whatever. Me personally, my Twitter handle is, and maybe we can put it in the show notes, it's XERAA. If you wonder why that is my Twitter handle, it's a rot 13 of my last name. if people still remember what ROT 13 was, it's like when you rotate the letters by 13. The nice thing about ROT 13 is it's like encryption and decryption is the same. So if you rotate by 13 again, you're back at the original. So if you take my last name and you rotate the letters by 13, this is the handle that I try to use everywhere. I learned about that, I think, when I was in school, and I was on a tram, and I basically on a piece of paper, I kind of like did the 13 calculation. And since then I have been sticking or using that.
How do you pronounce it?
Yeah, I say Xera, but there is no official pronunciation. I didn't put it in any Urban Dictionary or anything yet. I have an explainer on my website.
I saw that. Yeah.
I haven't added the pronunciation there.
Okay, there you go. Yeah. So awesome. Well, Phil, it was great to have you. I really appreciate it, and thanks for coming on.
Thanks for having me.